to our third episode on antibiotics. I hope you guys have been doing well. It has been an interesting journey till now. We began our sessions from first episode, second episode, and now we're in third episode. The first episode, basically, we began by looking at the introduction to bacteria. How does bacteria look like? And what are the major differences when it comes to gram-positive and gram-negative bacteria? What is constituted in the bacterial cell wall, like the peptidoglycan layers, and why is gram-negative more resistant compared to gram-positive. So this we did at our first session, and I hope you guys watched it. If you haven't watched, you can go back and look into it. So after looking at the approach of how bacteria looks like, we began our class by tackling some of the antibiotics. Now, I told you guys that when it comes to fighting bacteria, our drugs tend to act on various sites. Let me say three major sites. They work by attacking the cell wall, they work by attacking the cell membrane, and lastly, they work by attacking or interfering with the composition of the nucleus. So, on our second episode, we looked at how or some of the antibiotics that work by interfering with the structure of the cell wall. And there we named two major groups, those that inhibit the structure of cell wall by interfering with the synthesis of the peptidoglycan layer, and those that work by preventing the cross-linking of the peptidoglycan layer. So the drugs that work by interfering with the manufacturing of the peptidoglycan layer, or the vancomycin and the pheomycin. We looked at those that work by interfering with the structure of the cell wall by preventing the cross-linking of the peptidoglycan layer, and these are the beta-lactam antibiotics. And we looked at the natural penicillins, we looked at anti-staphylococcal penicillins, the aminopenicillins, the anti-pseudomonal penicillins. We looked at the cephalosporins, the monobactams, and the carbapenems. I hope you guys looked into them. So today we are going to jump. So after looking at the cell wall and some of the antibiotics that work by interfering with the cell wall, today we are going to move on now towards the cell membrane. So we have got drugs that work by interfering with the structure of the cell membrane. Now, number two, so section B here, we will write cell membrane. So by now, I hope you guys have looked. On our first class, as I said before, we looked at cell wall, as you can see here, cell wall, and some of the antibiotics that work on the cell wall by decreasing the synthesis of the peptidoglycan layer. And this is the vancomycin and the physiomycin. We looked at those drugs that work on the cell wall by decreasing the cross-linking of peptidoglycan layer, the beta-lactam antibiotics, the likes of natural penicillin, the pen-G and the pen-V, the anti-staphylococcal penicillin like the flucloxacillin, the nafcillin, the dicloxacillin, the oxacillin, and the cloxacillin. We looked also at the aminopenicillins, the amoxicillin, and the ampicillin. But here we said that this category, they tend to be more susceptible to beta-lactamase. So here we tend to combine these two drugs with beta-lactamase inhibitors, the likes of clavulanic acid and the sulbactams. We also looked at anti-pseudomonal penicillins, the like of peptazo, the ticagrelin, the meslocillin, and the azlocillin. We looked also at the cephalosporins, the 5 generations, the first gen, the second gen, the third gen, the fourth gen, and the fifth gen. We also looked at the carbapenems, and here we added a very crucial point that one of the carbapenems, the imipenem, is always easily degraded by the kidney, and that being said, we tend to co-administer it with cilastatin. We also looked at the at monobactams, one which is called as stionam, which is only effective when it comes to acting against gram-negative aerobes. But here also we say that it's always an alternative when a client has got a gram-negative bacteria but is allergic to penicillin. We can issue as stionam. So that being said, today we're going to jump on the cell membrane. Now we have got other antibiotics that are very much effective when it comes to acting on the cell membrane, and here you have got two major ones. The first one that you'll come across is called daptomycin. Now daptomycin is a very interesting drug. To make it easier for you, it works basically by creating an efflux pump in the cell membrane. It creates an efflux pump in the cell membrane. By doing this, it will lead to the cell will lose its content. Once the cell membrane becomes porous, it will easily lose its content. Other important thing that you have to know, and so for those guys who are new, for those guys who never watched my first episode, cell membrane is very crucial for the bacteria, and we all know that it works by controlling the osmotic pressure and molecular transport. So disrupting this layer will cause rapid leakage of intracellular content leading to cell death. So cell membrane is very vital when it comes to bacteria. So by interrupting or by destroying the cell membrane, it means that you'll have an upper hand in killing the bacteria. So the first drug that acts on the cell membrane is the daptomycin. Let me just highlight it in green. That's the first major drug that works on the cell membrane. Number two is the colistin, the colistin or colistin, whichever way you may call it. I call it colistin. But other books or some people use the scientific name polymyxin E. I think so. That's the polymyxin. I think that's the spelling. I don't know why it's highlighting it in. I think this is the spelling. Polymyxin. Is it okay? Polymyxin. So polymyxin E or colistin is another drug that is very much effective when it comes to acting on the cell membrane. So these two drugs are the major drugs when it comes to acting on the cell membrane. The colistin or polymyxin E, basically this just disrupts the cell membrane. Disrupt the cell membrane, causing leakage and death, cell death. So yeah, so those are the two major drugs that work on the cell membrane: the daptomycin and the colistin or the colistin. Now, when it comes to treatment, why do we use daptomycin? Daptomycin is very much effective when it comes to MRSA. Yeah, it's a very good drug. It's very effective when it comes to MRSA, but also it's very good when it comes to VRE. So VRE is a term that, for those who are new, it basically refers to vancomycin resistant enterococcus. For a reminder, you guys, when we tackled our second episode, we talked about vancomycin. Vancomycin is a very good drug, actually, very very much effective when it comes to MRSA and C. difficile. But one thing, there's some enterococcus that tend to adapt when it comes to vancomycin, and they may become resistant. So when there's a VRE, when enterococcus is resistant to vancomycin, we may tend to use daptomycin. I don't think. Let me just add one NB here. So vancomycin is not used for pneumonia. Why? It's for those guys who doesn't know this one content here. Daptomycin is rarely used for pneumonia. Why? So daptomycin is not effective for pneumonia because it's always inactivated by surfactant. So you can just add here it's not effective, or let me say ineffective. If that's a good English, ineffective. Is that English? Let me say ineffective or ineffective. Let me say not effective. So it's not effective against bacterial pneumonias, against pneumonia, because of its inactivation by surfactant. So this drug surfactant, yeah. So this drug is not effective when it comes to pneumonia because the surfactant will inactivate it. So that you can note. So these are some of the indications when it comes to using daptomycin. It's very good against MRSA and also can be used for vancomycin resistant enterococcus. Colistin is a very good drug and a very bad drug. Why am I saying those two? So it's a good drug because it's always the last resort. Now, if a client is being treated by antibiotics, and this client has been using antibiotics offshore, he has been using antibiotics of the counters, not following the doctor's prescription, and the bacteria that is in the client system is resistant to various antibiotics. Maybe the doctor uses ceftriaxone, is not working, the flagile, the the amoxicillin, all these drugs are resistant. So when other drugs are resistant towards the bacteria, the last resort is always colistin. It's a very good drug. Last resort, sorry, it's a last resort antibiotic. So it's always the last solution when it comes to dealing with resistant bacteria. So when we have got resistant bacteria, let me write here for last resort for severe life threatening infections caused by MDR. MDR is multi-drug resistant mostly gram-negative bacteria, because this is the drug that tends to be more resistant. Bacteria that don't respond to safer alternative antibiotics. Yeah, so colistin is a very good drug because it's always a last resort for antibiotics. Last resort antibiotics for severe infection that are not responding to much safer options. So it's always a very good drug. Why is it bad? It's bad because it's always nephrotoxic. So it's very lethal to our kidneys, and that's why it's not normally used. But when we have no any other option, we will be forced to use it. Yeah, because when it comes to life and death scenario, we just have to try and utilize it. So let me just write this in blue. So those are the two major drugs when it comes to the cell membrane. You've got the daptomycin and the colistin, or the polymyxin E. So those are the two major drugs that are used, two major antibiotics that are very much effective when it comes to acting on the cell membrane. Let's look at the side effects. Let's begin with daptomycin. What are some of the side effects of daptomycin? The first major side effects when it comes to daptomycin is always muscle toxicity. This is a very broad side effect, but if you want to narrow down on it, we can write that. So what happens? This drug causes something called CPK elevation, the creatinine phosphokinase elevation, but it tends also to cause myopathy and a condition called rhabdomyolysis. So myopathy and rhabdomyolysis. What is rhabdomyolysis? Now, rhabdomyolysis is a very rare but common condition. How? It's a clinical syndrome that involves breakdown of skeletal muscle fibers, and when a muscle fiber is destroyed or broken down, it will lead to elevation of myoglobin. So clients with rhabdomyolysis, they always have an elevation of myoglobin in their bloodstream. And we all know that myoglobin is very much nephrotoxic, and it can easily cause AKI, acute kidney injury. And one of the major symptoms of rhabdomyolysis is just check the urine. It's always tea-colored in appearance. Yeah. So rhabdomyolysis basically is elevation of myoglobin in bloodstream, which may interfere with the kidneys, and it's always caused majorly by the breakdown of the skeletal muscle fibers. So those are the two major conditions or major side effects of the daptomycin. Don't forget about rhabdomyolysis and myopathy. So if the client is under daptomycin and you see the appearance of urine is odd, tea-colored urine, then you have to either stop the antibiotic and look for a better alternative. Apart from the side effects of daptomycin, let's look at the side effects of colistin. Now, I told you guys that colistin is a very good and bad drug. It's a good drug in that when we have no other option, we decide to use colistin as the last resort, especially for those clients who are resistant, especially those clients whom they are resistant towards safer antibiotics. So we tend to use colistin as the last option. But also, apart from being good in that is the last resort, it's also bad because it's extremely nephrotoxic. So that's one of the major side effects of colistin nephrotoxicity, but it may also cause neurotoxicity when used when used in higher doses, or when there's an elevation of colistin in blood. So those two are the major side effects when it comes to using colistin. So I think until there we are together. I think we are together till there. So those are the drugs that work on the cell membrane. So if you think of antibiotics that work on the cell membrane, think of daptomycin and think of colistin. If you don't see colistin, look of polymyxin A. Those are the drugs that are much effective when it comes to working on the cell membrane. Yeah, so that's all about cell membrane. Now let's move to the next one. Remember, in our first session, in our first episode of antibiotics, we went through bacteria structure, and I told you guys that the three common areas that the antibiotics tend to work on, number one is the cell wall, cell membrane, and also the components of the nucleus, like the DNA, the protein synthesis, uh, the the folic acid pathway that is used by the bacteria to manufacture the RNAs and the DNAs. So those are some of the sites that the antibiotic tends to work on. And so far by now, we have looked on the antibiotics that work on the cell wall, and we have also looked on the antibiotics that work on the cell membrane. So we are going to move on the next session, which is broad and very detailed, and we're going to check now on the drugs that work on the components of the nucleus, the DNAs, the RNAs, the protein synthesis, reversible subunits. We're going to look on the folic acid pathways and have an understanding on some of the drugs that work on these areas. So point number C, let me just climb up. I think so far, yeah, that's well done. Now here we are going to begin now looking on the components, the nucleic structures, the nucleic components, the genetic components of the bacteria, and how we can interfere with that aspects of the bacteria. Now here I'm going to look at the folic acid pathway, and I'm going to write here interference. I think that's the spelling. Now interference, let me put in caps. We can put here nucleus components. Yeah, I think that's a very good term to use. This will be our C. And now here, our first area, we're going to look on the interference with the folic acid pathway used in synthesizing DNA and RNA. Yeah, interference in the folic acid pathway that's used by bacteria in synthesizing their DNA and their RNA. I hope we're together. Yeah, so we all know that bacteria also, they have their own DNA and their RNA, and for them to have these, they have to manufacture their own. Yeah, and they always have a pathway that they use when it comes to manufacturing their own DNA and RNA. I'm very certain you guys, when you did your anatomy, genetics, you looked on the composition of the DNA and the RNA. And I'm very certain you guys, when you are taught the composition or the components or the structures of the DNA, we looked at the DNA is majorly composed of the, and like DNA, when it comes to DNA, you've got the oxyribose sugar, we have the phosphate bound, and also we have got the we have got the deoxyribose, the phosphate bond, and also the nitrogenous bases, the likes of the adenine, guanine, cytosine, yeah, and thymine, all those that you are taught when it comes to genetics. So here we are going to look on how the bacteria manufactures or synthesizes its own DNA and RNA, and it does this by using the folic acid pathway. I have a diagram here. You see this diagram here. So how does it work? It's a very simple to understand. The first step, the bacteria also always use PABA, the para aminobenzoic acid, and there's an enzyme called dihydroteroate synthase that converts the PABA to dihydroteroate. So here there's a first enzyme. The first enzyme that is very crucial in this process is the dihydroteroate synthase. Now, once we have got the dihydroteroate, next step is we've got another enzyme called the dihydrofolate synthase. So dihydrofolate synthase converts the dihydroteroate into dihydrofolate. Once we've got the DHF now, another enzyme that is involved here now, another enzyme which I've said is dihydrofolate reductase, converts this DHF into tetrahydrofolate. Now, DHF or the tetrahydrofolate is used to manufacture, number one, it's used for manufacture the purines. Yeah, the purines, number one, the purines basically it's what makes the composition of the DNA, the adenine and the guanine, and also the thymidylate. So the tetrahydrofolate is the final component which the bacteria uses to manufacture the purines. Purines, here we have the adenine and the guanine, which are example of the nitrogenous bases used to manufacture or make the DNA, but it also makes the thymidylate. So that's the process. Now we have got antibiotics that work by interfering in this process, and these antibiotics, they target these enzymes, the two major enzymes. The first antibiotics fall under category sulfonamides. They work by interfering with the enzyme dihydroteroate synthase. These are the sulfonamides. We have also other antibiotics that work by interfering with the second enzyme that is called the dihydrofolate reductase, and that antibiotic is called the trimethoprim. So the sulfonamides work by inhibiting the first step, yeah, the first enzyme, that is the dihydroteroate synthase, and the second step, the second enzyme that is involved in the second step, the second enzyme called dihydrofolate reductase, is inhibited by trimethoprim. Yeah. So that being said, let's come now to our table and make it easier. Now, the first drugs that interfere with the nucleus composition, all those processes, are the drugs that interfere with the folic acid pathway. Folic acid pathway is an important pathway that the bacteria uses in manufacturing the tetrahydrofolate. Tetrahydrofolate is very crucial when it comes to making the purines, the adenine and the guanine, and also the thymidylate. So that is what you have to know. So the drugs that are used here, the first category, are the sulfonamides. The sulfonamides, yeah, that is the first category. And just to make it easier, and in the bracket, these are drugs that inhibit dihydroteroate synthase. These are the drugs that inhibit dihydroteroate synthase, yeah, the sulfonamides. I hope you're together till there. The second group that you have are the trimethoprim. Trimethoprim. I think that is easy to understand. Now this one here, they inhibit the second step. They inhibit the enzyme involved in the second step, and this enzyme is called dihydrofolate reductase. Yeah. And lastly, now to make it more easier to understand, we always use a combination, a fixed dose combination called cotrimoxazole. I hope you guys have come across this drug, the CTX, the cotrimoxazole. Now this basically is the combination of sulfonamides and the trimethoprim. And one example of sulfonamides, let me just put here, the common example of sulfonamides, the one that's most commonly used is the sulfur methoxazole. That is the major common sulfonamide that's used, the sulfamethoxazole. So when it comes to drug combination, now we always combine the two. So when used alone, they tend to be bacteriostatic. The sulfonamides are bacteriostatic. The trimethoprim also are bacteriostatic. They stop the growth of the bacteria. But you can make them bactericidal by combining both. So the cotrimoxazole tends to be bactericidal. Yeah. So we always, to make it more convenient or more lethal, we combine the two to form cotrimoxazole. So in bracket here, we can put a combination of the sulfur methoxazole combined with trimethoprim. So if you combine the two, we form cotrimoxazole. Yeah, that's the two drug combination. I hope till there we are together. And now the cotrimoxazole tends to be more bactericidal. Yeah. Now, when it comes to treatment, why, under which circumstance do we use this drug? So the sulfamides are broad spectrum, very much convenient against gram positive and gram negative bacteria. Gram negative bacteria. Yeah. So it's very much broad spectrum against gram negative and gram positive. Trimethoprim is mainly used for treating UTIs, the urinary tract infection, those that are mostly caused by E. coli. So if you've got an UTI caused by E. coli, you can use trimethoprim, or those caused by Klebsiella or Proteus mirabilis and others. It's also very much convenient against prostatitis. Is this the spelling? Prostatitis. The inflammation of the prostate gland. I think that's also very much common. The infections, the bacteria that cause prostatitis, we can also use trimethoprim. And the RTIs, the respiratory tract infections, yeah, like those caused by strep. So those are some of the category. Okay, like let me just put here strep. Those caused by strep. We can also use the trimethoprim. But coming across these drugs that are used as a single dose is very rare. We tend to see this drug as a combination. If you go to the pharmacy, getting sulfamethoxazole in its own is rare, but I'm very certain if you go to ask for cotrimoxazole drug, you'll come across it. So we always see it as a combination drug, as a fixed dose combination drug called cotrimoxazole, and it's very good for those clients who have got UTIs. If you've got UTIs, because of bacteria, it's very common. RTI is very common against RTIs. And one unique thing about this drug, let me just highlight here, when it comes to respiratory tract infection, there's a very common pathogen that ain't a bacteria, but is always worked on by cotrimoxazole, the CTX. This one pathogen that one pathogen that is not a bacteria, but it's very much when it comes to using the CTX drug, it's very much convenient when using it. And this pathogen here is a fungi. If you do mycology, there's one fungi called pneumocystis. Another one, gyrovecii. Is this the spelling? Pneumocystis gyrovecii pneumonia. It's a very common fungi for those clients who have got low immune system, for those clients who the immune is weak. So this pathogen tends to appear. It's a fungi. I think it's a fungal. It's a fungi. Very common for those guys who have got low immune. Yeah. And CTX is very good when it comes to against this. This fungi causes pneumonia, but if you use CTX, it tends to be very much convenient when it comes to it. So that pneumocystis gyrovecii pneumonia, it's not a bacteria, but CTX works well against it. Another condition that we can use, another indication when it comes to using CTX, it's community acquired. There's a community acquired MASA. community acquired methicillin resistant staph aureus. Also, we may use these skin infections. So the skin infection caused by MRSA, we can also use the CTX, yeah, in treating it. They're also used prophylactically against various conditions, and they can also be used against complicated and complicated UTIs that I've mentioned. So these are some of the indications when it comes to using either the sulfonamides, the trimethoprim, and the cotrimoxazole. So let me just highlight it in blue. Let me give them the blue highlight. The blue highlight. I hope till there we are together. In this group, I think the drug that will come across it in common, the most famous drug in this category is the cotrimoxazole. Just know that these drugs works by inhibiting those two steps that are used on the folic acid pathway. They act on the dihydrofolate synthase by the sulfamethoxazole, and they also act on the dihydrofolate reductase through trimethoprim. Now, let's come to the side effects here. Now, the side effects of using sulfonamide. The first side effect I will say is hypersensitivity. Hypersensitivity. So, sulfonamides, you have to check the hypersensitivity reaction. It may range from mild reaction by just mild skin rashes or to severe. And which severe skin reaction can this drug cause? SJS, called Steven Johnson syndrome, a very bad skin condition. So it may be range from mild to severe, like Steven Johnson syndrome. It may also present with crystal in urine, crystalluria. I think that's the spelling, crystalluria, crystals in urine. Also, we may see canicterus. Someone is asking, what is canicterus? Now, let me just explain in canicterus, very common in neonates. This is what happens for those pregnant women who are in the third trimester towards delivery, or neonates. If these groups of people, the pregnant women who are towards delivery and the neonates, the sulfonamides always tend to displace bilirubin from the albumin. We all know that albumin is an example of plasma protein that tends to transport bilirubin. So if you give sulfonamide, these drugs, to a neonate or in late pregnancy, this drug will separate bilirubin from the albumin, and this will cause hyperbilirubinemia, elevation of bilirubin in blood. Now, bilirubin can easily cross the blood-brain barrier because the blood-brain barrier is not well mature in the neonates. So when it crosses the blood-brain barrier, it may cause a permanent brain damage, and that is what we call canicterus. Very much common in neonates. So if a neonate, so that's why I think it's contraindicated. I think this drug is not used for neonates, yeah, because it may cause severe jaundice. You may see jaundice in neonates, and this is because this elevation of bilirubin, it can cross the blood-brain barrier and cause severe permanent brain damage. Which we call it canicterus. I think till there you're together. Another one, it causes something called G6PD deficiency. G6PD deficiency. Now, G6PD means glucose 6 phosphate dehydrogenase. This is called glucose 6 phosphate dehydrogenase. We are not doing a biochemistry class, but that's just what you should know. So G6PD deficiency is a genetic disorder that affects the RBC. Let me just put here in comma. Genetic disorder affecting RBC, yeah, red blood cells, it may cause hemolytic anemia, yeah, causes hemolytic anemia. I think till there we are together. For connectors, let me put this also this in comma. Connectors have explained this basically can say is bilirubin induced neurologic dysfunction. Yeah. Don't worry. I think most of these things you'll know when you tackle either med-surg or you tackle the pediatrics units, or if you do the pathology units, you'll be able to understand better. So a summary. So for sulfonylureas, they cause Steven-Johnson, they cause crystalluria, they cause connectors, they cause G6PD deficiency, causing hemolytic anemia. When it comes to trimethoprim, this one, they tend to cause folate deficiency. And if we hear folate deficiency, what comes in our mind? There's an anemia. Folate deficiency, think of megaloblastic anemia. So here, megaloblastic anemia. Yeah, this is majorly caused due to folate deficiency. Sorry for the spelling. This is deficiency. That's the spelling. Folate deficiency, it may cause megaloblastic anemia. This one, it may also cause elevation of potassium levels, hyperkalemia. So these are the major side effects when it comes to using trimethoprim. Hyperkalemia, this is what's the spelling of hyperkalemia? Hyperkalemia. I think this is spelling. Hyperkalemia. Yeah. So those are the two major side effects of trimethoprim. Now, I think now it's easier for you to write side effects of cotrimoxazole. So you just, if you for this cotrimoxazole, basically is the combination of those side effects of the trimethoprim and the sulfonamides. So if you take these two, all these side effects and this one, they form the side effects of using the cotrimoxazole. So just make a summary. For JT, it causes nausea, vomiting, diarrhea, very common. For skin or the integumentary system, it may cause mild rash, especially when you're using sulfonamides, or the Steven-Johnson syndrome. When it comes to the hematology, it may cause megaloblastic anemia. This is very much common with trimethoprim. Megaloblastic anemia. It may also cause something called hemolytic anemia. Why? Because it causes G6PD or glucose 6 phosphate dehydrogenase deficiency, causing hemolytic anemia. Hemolytic anemia, and also causes bone marrow suppression. Causing this may cause leukopenia, decrease in WBCs. It may cause thrombocytopenia and also anemia, thrombocytopenia and others. Yeah, so that's some of the common side effects. And let me continue. Also renal, it may cause what? It may cause crystal in urine, crystalluria. This one is majorly seen in sulfonamides. It may also cause electrolyte imbalance. Why electrolyte imbalance? Because you have said that the trimethoprim causes hyperkalemia. So this is majorly seen in hyperkalemia. So if a client is on CTX and also potassium sparing diuretics, the likes of spironolactone, yeah, you have to be very vigilant when it comes to electrolyte imbalance, because those drugs may potentiate hyperkalemia. And let me add the last one, neonatal. Here you have said these drugs are rarely used for neonates. If a neonate has got an infection, you rarely see a prescription of CTX because it may lead to canic canic canicteras. Yeah. So that are example of the side effects when it comes to using the cotrimoxazole. Yeah, so I think you're going to stop there. I'm going to stop there. It was a good session. I think I'm exhausted, but I think you have learned something today. You have looked on. I've continued this episode number 3. You have looked on antibiotics that interfere the cell membrane, the daptomycin and the colistin. The daptomycin destroys the cell membrane by causing an efflux. Colistin disrupts the cell membrane by causing leakage and cell death. We have looked at some of the indications and side effects. We have also looked at antibiotics that interfere the nucleus components. You have begun by looking at the interference with the folic acid pathway. And this have said there are 2 major steps. The first step is by inhibiting dihydroteurate synthase, and the second step is by inhibiting dihydrofolate reductase. And the first step, the antibiotic that works by interfering the first step is the sulfonamides. An example is the sulfamethoxazole. And the antibiotic that interfere the second step is the trimethoprim. And you can also use it at a fixed dose combination whereby we combine the sulfamethoxazole and the trimethoprim to make it more bactericidal. I've looked at the common indications, but here I want you to remember the cotrimoxazole is very good drug used prophylactically. You can also see it being used for those clients who've got low immune and have fungal infections like the pneumocystis jirovecii pneumonia. Very good on using it. And also the MRSA causing skin infection. Also the UTIs, those caused by the E. coli, the Proteus mirabilis, and the others. You can also use the cotrimoxazole. So the first, you have to be very vigilant here. Think of the Steven Johnson syndrome when you are using sulfamethoxazole. Think of canicteras. Think of the G6PD deficiency. Think of the crystalluria when using sulfonamides. Think of the megaloblastic anemia when using the trimethoprim and the hyperkalemia. But basically, the combination of the side effects when using the CTX, it will cause the combination of the side effects, the GIT, the nausea, vomiting, diarrhea. It will cause the mild rash, the Steven Johnson syndrome. Hematology, it will cause the megaloblastic anemia, the G6PD deficiency, causing hemolytic anemia. You've got the bone marrow suppression. We also have the crystalluria, the hyperkalemia, and the canicteras. I think if you just look onto this table, you easily have a clear understanding, a clear summary on what you have to know when it comes to use to antibiotics that interfere with the cell membrane and that interfere with the folic acid pathway. Thank you for this session. If you are new, go look into our first episode and our second episode to catch up on this third episode. So we're going to our next class. We're going to look on the 4th episode. This series is very long and short. If you're together in this class, I believe that you'll be able to tackle some of the questions that come in your exams. And if you're a clinician, a nurse, you'll be able to refresh your knowledge concerning the same. So subscribe, click the like button. Let's support each other. If you are new, please subscribe and share the message to your classmates or your fellow healthcare worker, just for us just to have an understanding on this pharmacological drug.